We're here with our Extension Ag engineer, John Long, talking sprayer nozzles. And John, you kind of have a little system set up here. Kind of give us a little overview of what you have going on.
Yeah, sure. So what I've got here is what we call our spray table. It's basically just a setup that's designed I can take to different events, a lot of meetings across the state as far as both youth and producers, and just gives us a way to demonstrate what happens in an agricultural spray rig as far as being able to recirculate water and look at different nozzle types, show different things like wear and that kind of thing.
So is this one an older or newer model than this one? How are these two different?
So I've got a couple different ones here, but the ones I have selected here, this is just a extended range flat fan nozzle that's kind of I guess the technology has been out for many years. These used to come in brass and stainless. You can still get them in those materials now, but a lot of them come in plastic and metal inserts. And it's just a flat fan nozzle. It's used a lot for a lot of different broadcast applications and that kind of thing. The one I have on the right here that's selected is an air induction style tip. This happens to be a two-piece tip, but it basically draws air into the system, mixes air with the water, and creates much larger droplets than the small tips at the same flow rates.
So when you're applying these out in the field, like what type of situation would you be using these for? Where would they come into play?
So both of these are flat fan nozzles. They would be used on a broadcast application sprayer. So you would have them on a boom spacing just like I have here. The original flat fan here, extended range, those can be used for a lot of broadcast applications, but they're really good for where you need a lot of coverage because they produce a lot of smaller droplets, especially at higher pressures, whereas the air induction style nozzles are used in areas where we want larger droplets, and they're going to be used a lot of times in places where we're applying herbicides, especially systemic herbicides like Roundup and those types of things.
Can we actually turn it on to see kind of what the difference
is?
Sure,
yeah. So we've got the two nozzles here, they're set up, and if you can take a look here just from the visual standpoint, you can see that there's much finer nozzles or droplets coming off this nozzle versus our air induction. You can also really kind of hear the air induction a little bit, drawing that air in and mixing it. If we look at the nozzle itself, there's a lot of fines coming off of this particular one. And if I increase the pressure a little bit, so we're running at 40 PSI. If I increase the pressure just a little bit more, we get even more fines kind of rolling off of this one. So that's one of the issues we have with these nozzles. They provide a lot of fines for good coverage, but we get a lot of those that could be driftable.
So why the change between the two? Like what brought that about?
So there's been a lot of changes in any industry over time as new technology, new materials come out, but drift is a big thing that I already kind of hit it on there. Is that, that's one of our concerns. We want to make sure that we're applying our herbicides, our insecticides where we want them to go. It's been a big thing in the news lately in the past couple of years especially, but we want to make sure we're using our resources wisely. We're getting good effective kills on the pests that we're trying to control, and also we're able to not damage our neighbors and cause other issues from drift coming through.
All right, thanks John. And if you would like any more information on that, you can go to our website, sunup.okstate.edu.